Moving machines generate reaction forces and moments. This leads to noise, wear, and fatigue problems. This is particularly drastic in the case of manipulator motion on aerial vehicles, where the couple dynamics affects the trajectory of the vehicle, as can be seen in the video on the right. Dynamically balanced mechanisms can be a solution to these problems, since they do not generate any reaction forces and moments. And the design is such that the linear and angular momentum is constant. There have been many research efforts towards the development of force and dynamically balanced mechanisms, but this research has either been restricted to planar mechanisms or led to development of complex, heavyweight spatial mechanisms. Consequently, mechanical design that are balanced has not been looked into much while designing aerial manipulators. To tackle these problems, we present the Adapt Manipulator, which is a lightweight 3 degree of freedom parallel manipulator with pantograph legs. The design is such that the motion of the platform in its configuration space doesn't lead to any reaction forces. This is especially helpful in aerial vehicles since the manipulator would not have any mass terms in the coupled inertia matrix, making the manipulator behave like any static mass. In the paper, we present the forward kinematics and the inverse kinematics, which is slightly different than the conventional robots, since the actuator is on the second joint. We also talk about the constraint singularities in the paper and the similarity to the Dynamo robot. To validate the design, a simplified model was simulated on atoms, which confirmed the reactionless behavior. The experimental setup was also built, and static and force balance tests were done. Since the structure doesn't have any spring elements that can store potential energy, static balancing should also prove that the system is force balanced. Next, the counterweights are removed to create an unbalanced situation. We see that the platform does not maintain its position as it did in the balanced case. The force balanced test, the platform was moved forward in the x direction and back. The following reaction forces were obtained with a 1 degree of freedom bidirectional sensor. The reaction forces were not completely zero in the balance case due to manufacturing inaccuracies which led to backlash and stiction, but this can be overcome by better manufacturing. Thank you.